Hello everyone, I am Dr. Ritesh, working as an assistant professor in Department of Physiology in New Delhi AIIMS. Today we are going to discuss about the regulation of acid-base balance. So I expect at the end of this module, a student should be able to define what is acid, what is base, and you should be able to enumerate three important mechanisms by which body maintain acid-base balance. You should be able to explain the importance of acid body fluid buffers. You should be able to tell how lung is important to maintain acid base balance. You should be able to tell fast acting and slow acting mechanism of acid base balance, and you should be able to justify need of all three mechanisms to maintain acid base balance. And you should be able to enumerate different acid base disorders. So the overview of this session will be what is acid and what is base. First we will discuss this thing, then the importance of acid base balance, then regulation of acid base balance, then some applied aspect, and at last summary. So what is acid, what is base? Acid, any molecule which contain hydrogen atom and able to release hydrogen ion, known as the acid. A strong acid, those are those molecule which rapidly donates hydrogen ion, for example HCl, and weak acid are those which releases hydrogen ion slowly, for example H2CO3. Base is any molecule that can accept hydrogen ion, known as a base, for example HCO3 and HPO4. Acid base balance. So why the acid base balance is very important for our body? Hydrogen ion concentration in your body should be maintained within a narrow range, because the change in the pH or hydrogen ion concentration influences the enzymatic activity in the whole body. So it is essential to maintain pH or hydrogen ion concentration for the vitality of the cells. Hydrogen ion concentration is maintained in the same way as the other ions in the body. It is basically balance between intake and production of hydrogen ion in the body with removal of the body. Kidney plays essential role in maintaining balance of the concentration of hydrogen ion, and this concentration of hydrogen ion is kept within a very narrow limit, about 0.004 milliequivalent per liter, which is 3.5 less than the sodium concentration, which shows need of multiple and dynamic regulatory measures for maintaining hydrogen ion concentration within narrow range. Normal variation can be seen in the day-to-day life on hydrogen ion concentration in 3 to 5 nanoequivalent per liter on extreme condition without causing death. From it can vary from 10 nanoequivalent to pH is a basically negative algorithm of H plus ion concentration. So normally it is 40 nanoequivalent per liter. So pH of the body is 7.4. The pH, the body fluid having a different pH, because body have different body fluids. Now we are going to discuss about the mechanism to maintain H plus ion concentration in our body. There are three mechanisms, and first is the body fluid chemical buffers that acts rapidly but temporary. Bicarbonate, protein, phosphates are the example. Second is the lung, which acts very rapidly, and third is the kidney, which acts slowly, which eliminates non-volatile acid body fluid chemicals. This body fluid system buffers includes weak acid, that is H2CO3. It is formed by reaction of the CO2 and H2O in lung in presence of the carbonic anhydrase. It has a weak tendency to break down on H plus ion and bicarbonate, and a strong tendency to maintain H2CO3. So that is why the concentration of H plus ion is less, but when any strong acid is added in the body, it provides additional H plus ion which binds HCO3 and produces H2O and CO2. This additionally produces CO2, stimulates respiration and eliminates CO2. It is most powerful extracellular buffer system in the body. Second is the bicarbonate salt. It has a strong tendency to ionize with sodium ion and bicarbonate ion. When a strong base is added to the body, it reacts with H2CO3 and form NaHCO3, Because of that, there is a decrease in the concentration of HCO3, which is compensated by using carbon dioxide. So net result is decrease in CO2 in blood, which lead to decrease in respiration. Before going to discuss any acid base balance, first we discuss the Henderson-Hasselbalch equation. This equation is by this equation, pH of the solution can be driven by if the concentration of bicarbonate and partial pressure of CO2 is known in the solution. Third is the phosphate buffer system. It is not an important extracellular buffer system as bicarbonate, but plays an important role in buffer system in the renal tubule as an intracellular buffer system. Operating range of phosphate buffer system is 6.8 and tubular fluid is slightly alkaline. That is why the phosphate buffer system is more effective buffer in renal tubules. Phosphate concentration is very high in intracellular fluid as compared to extracellular fluid, and pH of intracellular is slightly alkaline, which makes phosphate buffer system more effective as intracellular buffer system. Fourth is the intracellular protein. About 60 to 70% of total chemical buffer in the body is present intracellularly, and its operating pH is also very close to 7.4. That is why this is a very important buffer system, but it takes several hours to become maximum effective. Now we are going to discuss about the second part, that is lung, which is rapidly acting. It is a second line of defense after body fluid, which acts within seconds and minutes. As mentioned by Henderson-Hasselbalch equation, pH of body is dependent on the two parameter, that is the concentration of HCO3 and partial pressure of CO2. If all the factors are remaining same, then the higher the alveolar ventilation lead to lower the partial pressure of CO2, decrease in the concentration of HCO3 and decrease in pH of body. And like we are going to discuss about the pH and the rate of respiration. So whenever there is increase in the rate of respiration, and it also affects the pH of our body. Not only ventilation affects the pH, the extracellular pH, but the pH also affects the rate of the respiration, which can be, and it can increase the ventilation up to 4 to 5 times if the pH of the body falls to 7.4 to 7. Lung is basically act as a negative feedback system to maintain the body pH within a normal range. Although it is a very effective and fast defense system, but it can correct changes in the pH up to 50 to 70% only if it causes the pH disturbance is extrapulmonary. Respiratory disturbance can also lead to the pH disturbance, for example respiratory acidosis. So now we are going to discuss about the role of kidney in acid base balance. Kidney can balance disturbance in the acid base balance by either forming acidic or basic urine. In normal condition, this balance is maintained by appropriate filtration of bicarbonate, secretion of H+ ion and reabsorption of bicarbonate. A total 4400 milliequivalent of hydrogen ion is secreted per day by the kidney, out of which 4320 milliequivalent of H+ ion are used to reabsorb and filter bicarbonate, and rest 80 milliequivalent of H+ ion is produced daily by the body, is extracted to maintain the normal acid base balance. By three mechanisms, kidney maintain the acid base balance. First mechanism is the secretion of H+ ion, second is reabsorption of filtered bicarbonate, third is the production of new bicarbonate. Bicarbonate absorption is differently reabsorbed in the nephron, which bicarbonate reabsorb and H+ ion is secreted in the proximal tubule, thick ascending segment of the loop of Henle and early distal tubules. Large amount of bicarbonate is filtered by the glomeruli, but for the reabsorption of bicarbonate it has to combine with H+ ion and it forms H2O and CO2 because luminal membrane is impermeable to bicarbonate. The process of reabsorption starts with action of sodium potassium ATPase which present in the basolateral side of the epithelial cell and lead to exchange one sodium ion for the one potassium and makes gradient for the sodium, and sodium is then exchanged by the sodium hydrogen exchanger in the apical side of the epithelial cell of H plus ion. This H plus ion is formed by the action of carbonic anhydrase by the H2O and CO2. Secretion of H plus ion reacts with filtered bicarbonate and form H2CO3, which dissociate into CO2 and H2O. Then CO2 again diffuses to epithelial cell to react with H2O in presence of carbonic anhydrase. This process of bicarbonate reabsorption and H plus ion mainly present in the proximal tubule and thick ascending segment of the loop of Henle and early distal tubule. In distal and collecting tubule, for the reabsorption of bicarbonate, there is a primary active transport of H hydrogen ion by hydrogen sodium ATPase at the apical site of the specific cell known as the intercalated epithelial cells. Hydrogen ion secretion in the distal and collecting tubule, a maximum of 0.03 milliequivalent of free H plus ion can be secreted in per liter of the urine, because minimum urine pH is about 4.5. If H plus ion remain free for excretion of 80 milliequivalent of the non-volatile acid in per day, it will be required about 2500 liter of the urine for the large amount of the H plus ion secretion. It has to combine with the other buffer tubules, that is phosphate and ammonia. Phosphate has an important role as a buffer for the H plus ion. When a filtered sodium hydrogen phosphate and comes in the contact with H plus ion, produces sodium dihydrogen phosphate, and luminal membrane is impermeable to sodium dihydrogen phosphate, so it is extracted as such. Important point here is to be noticed, bicarbonate is not exchanged for the filtered bicarbonate, as means there is a net gain of the bicarbonate ion. Similar gain of bicarbonate can be seen in proximal tubule as a production and secretion of ammonium ion, and in collecting tubule as a hydrogen ion secretion by ammonia. Now we are going to discuss about the buffering of the hydrogen ion secretion by the ammonia, and this is basically showing the net adding of the bicarbonate to the body, or and the titratable acid is 30 milliequivalent per day, by ammonium excretion 50 milliequivalent per day, bicarbonate excretion 1 milliequivalent per day, the total about 79 milliequivalent per day. Renal compensation for acidosis, the increased addition of bicarbonate to body by kidney, the increased H plus ion loss by kidney. Renal compensation for alkalosis, net loss of bicarbonate from the body, that is decreased H plus ion loss by the kidney. Regulation of H plus ion secretion and bicarbonate reabsorption by kidney. As mentioned earlier, bicarbonate absorption depends on the H plus ion secretion in the tubule. Because bicarbonate is not permeable to luminal membrane, after combining with the H plus ion, bicarbonate produces CO2 and H2O, which can easily cross the tubular luminal membrane. So, for daily normal life situation, kidney must produce sufficient H plus ion for reabsorption of bicarbonate and to titrate the other phosphate and ammonia buffer systems. So, in acidosis, kidney must secrete H plus ion in the tubule. So, all the bicarbonate must be absorbed and phosphate and ammonia buffer should be used, which lead to synthesis of new bicarbonate. In the body, opposite should happen to alkalosis, in which hydrogen ion secretion should be reduced, so less bicarbonate is absorbed in the body, and no utilization of phosphate and ammonia buffer. For example, new bicarbonate synthesis. So, there are many factors which can increase or decrease the H plus ion secretion and bicarbonate reabsorption by kidney tubules. Now, we are going to discuss about the classification of acid base disorders. To classify any of the condition of acid base disorder, following steps should be followed. Like, first of all, first you should know the bicarbonate concentration and partial pressure of CO2 in the arterial blood. From above two value are used to calculate the pH by the Henderson-Hasselbalch equation. After knowing the acidosis or alkalosis condition, next is to classify it is as a metabolic or respiratory origin. So, first partial pressure of CO2 is increased, then it is respiratory origin. If partial pressure, if the concentration of bicarbonate is decreased, then it is metabolic in origin. So, now we are going to discuss the renal compensation for acid base disorders. Acidosis basically increase in the H plus ion secretion, increased bicarbonate reabsorption, production of new bicarbonate. Alkalosis, in alkalosis there is a decrease in H plus ion concentration, decrease in bicarbonate reabsorption. Renal response to respiratory acidosis. So, basically there is a pH, low pH, high partial pressure of CO2, high bicarbonate, which lead to the complete bicarbonate reabsorption, which access the tubular hydrogen ion, which produces new bicarbonate that increases the pH of the body. So, renal compensation for the metabolic acidosis means there is a pH is low, the partial pressure of carbon dioxide is high and bicarbonate is low. So, basically for to compensate there will be complete bicarbonate reabsorption, which buffers excess tubular hydrogen ion, and also there is a production of new bicarbonate which increases body pH. Renal response to respiratory alkalosis means there is a high pH, low PCO2, low reabsorption of the bicarbonate. So, ultimately excess of tubular bicarbonate excretion and low hydrogen ion excretion, which lead to increase in the pH. Renal responses to metabolic alkalosis: low pH increased the production of bicarbonate and increased partial pressure of CO2, which is compensated by the increased bicarbonate excretion and decreased hydrogen ion excretion, which increases pH. Summarizing this slide is basically summarizing all the acid base disturbance and renal and pulmonary compensation. Now we are going to discuss about the acid base disturbance and its causes. Metabolic acidosis, it can be seen in the aspirin poisoning. So, basically there is increased hydrogen ion intake. It can be seen in diabetes where there is an increase in the H plus ion production. It can be seen in diarrhea where there is bicarbonate loss. Renal tubular acidosis, there is a decrease in the H plus ion and bicarbonate reabsorption. Carbonic anhydrase inhibitors, it can be also seen. Respiratory acidosis, that is seen in the hyperventilation. It can be seen when there is a brain damage or pneumonia or emphysema or other lung disorders. Metabolic alkalosis, which can be seen in increased base intake, vomiting gastric acid, mineralocorticoid excess or overuse of diuretics, or in the carbonic, except in the carbonic anhydrase inhibitors. Respiratory alkalosis can be seen in the high altitude or at the time of the fear or pain. So, in summary, I want to say H plus ion is precisely regulated in the body, and there are three systems that involves in acid base balance: body fluid buffers, which acts within second, lung, which acts within second to minutes, kidney, which acts within hours to day. And kidney maintains the acid base balance by secretion of H plus ion, reabsorption of bicarbonate ion, and by production of new bicarbonate. Kidney also eliminates non-volatile acids. So, this is all about the role of kidney in acid base balance. I hope you have learned about the acid base balance. Thank you.